My watch, it's exactly noon, so let's get started. Are you really, really tired at this point? Man, I'm going to have a hard job just keeping you awake in the next 75 minutes or so. I'm really tired as well, so I'll join your ranks. We're going to talk about forecast scheduling. Is it a fad or fundamental? Let's do a little pre-test or pre-check. Whom of you thinks it's a fad and it will go away just like the wind blows by? And whom of you think it's fundamental? All right. Well, we're all done with our presentation then, since you all agree. I can go home now. And or do you want to spend another few minutes with me, perhaps? So let's see what it is really all about. So that's me. I have now this MVP designation. It makes me a certified geek, or dare I say even freak. The new book is coming out. I'm currently writing it. We're almost there. You can pre-order it already. As you can see, we've changed the colors a little bit. Enough about that. Here's the agenda for my presentation. I'm going to show you how to capture the promises, particularly date promises. You need to do that in a particular way because otherwise you'll actually kill the forecast schedule, the dynamic model. I'm going to show you several different ways in which you can actually minimize your effort on scheduling. And then in order to do forecasting of a project, you really need to find a critical path, and there are some issues there that you need to be aware of and equip yourself with the right techniques to address those. And we'll talk a little bit about critical path. That's a standard that I initiated and wrote with a team a few years ago. And it's a challenge basically to software manufacturers like Microsoft, like Primavera, and other scheduling manufacturers to meet certain challenges. Because the critical path theory is already 50 years old, as you well know. Kelly and Walker designed it in the late 50s, early 60s. And it really needs a second version. And I'll talk a little bit about that. And then I'll talk a little bit about how to properly update your schedule. Such that you forecast with the schedule itself. Because that's basically the basic premise of forecast scheduling. How can you make the schedule by itself forecast and forecast your project well? If your schedule can do that, then you really don't need much more or even anything else. Why don't we have the schedule do that? So that's basically the target for my presentation. Just to paraphrase it, I'm going to rock your beliefs about scheduling and what a schedule is. I'm going to change your life, and we're going to rewrite the PMBOK. All right? Are you ready for it? So fasten your seatbelts. Here we go. Just going to touch briefly in each of these chapters in my book. This is basically the overview over all the chapters, just to give you a little bit of an idea where we'll make a brief landing. But it will be in just 75 minutes, obviously, just a very executive summary. First of all, what is a project schedule? Now you would say, Eric, come on. You're not going to explain that to me. Please, please, please. Well, let's talk a little bit about it, because if you stop a total stranger in the street out here in Anaheim, and you ask this person, what is the schedule? What is the project schedule? What will that person likely say? That is a possibility. I have no idea what you're talking about, of course. And somebody, a team member who might be on a project actually as a team member, what will that person say to be a project schedule? What they will likely say, does anybody have a suggestion? A list of things, right? And then their due dates, yeah, because that's the essence of a schedule, right? So if the whole world thinks about a schedule in that way, Are we as project managers and project schedulers also thinking about a schedule in that way? And the answer is no, we aren't. In fact, we are quite professionally deformed because we do all kinds of weird things with our schedule. But it's an essential question for each scheduler to resolve, and resolve early on in your professional life. Do you treat the schedule as a list of things to be created and their due dates? Or do you treat it as a dynamic model in which you manage the creation of it, and with which you want to develop what-if scenarios very quickly? This is a totally different world as that world. I've met actually literally schedulers who create a schedule, and then, I don't want this schedule to ever change. And they desperately try to keep it the same, right? And they basically smash it on their team and say, this is the way the project is going to unfold, all right? And they will not update their schedule. They use all either manually scheduled tasks, fixed duration, and hard dates in the schedule, and that's the way they try to run their project. Is that the way you are running your project? All right, I have some courageous souls who are indeed raising their hand. This is a totally different world. This is a world in which you will use a lot of dependencies. You will want everything to float back and forth. And perhaps a world in which you can also do this, that if one thing changes, you just have to update one cell in your dynamic model, and your scheduling software starts to work really, really hard for you. And it will tell you immediately if your schedule, if your project is still on time or is now behind. That's the idea here. I would like you to step up to this world. And for some of us, it will really require a dramatic change in attitude, how you're actually using this scheduling software. So do you really treat this as a static deterministic schedule, or are you out to create a dynamic forecast schedule? And I'm going to try to change you, if you're a static deterministic scheduler, to perhaps at least consider this world of dynamic forecast models. And the first step to try and perhaps convince you that this might be worthwhile is by looking at this. Let's look at what doctors do. Doctors have a patient. We have a project. Doctors have a control limit. Sorry, folks, I'm a European, and I'm in Canada, so I think in Celsius. So we have 37.5 degrees Celsius. That's a healthy body temperature. In Fahrenheit, it's about 98, I understand. And then they also have a measuring instrument with which they constantly monitor the temperature. You know, is the fever going up? Is it going down? Where is it going? And what you just need as a control middle limit in the schedule is a very simple thing. Just a deadline date. It's really all you need. You don't need to build a whole schedule if that's all you need. But the thermometer, the measuring instrument, that's where you need the schedule for. So this is an entirely different way of treating a schedule, because you're really going to treat the schedule as a measuring instrument. I always tell students in my class, what we're trying to do here is we're trying to build the perfect project thermometer that will constantly tell you and give you feedback. Where is your project? Is it sick? Is it feverish? Is the temperature high? Or is the temperature perhaps too low? Have you made it yourself too easy with negotiating the deadline? So those are some of the possibilities. As you can see, I'm treating this schedule as an entirely different thing than what a lot of people do. And I'm definitely treating it as an entirely different thing than what all your team members will see a schedule at. And worse even, how all your main clients, your executives, will treat the schedule, because they only think in terms of the schedule. Well, they often have only one final project product in their mind and one date, right? And that's all they really want to know about the project. So they also have very much that static deterministic kind of thing, and they really don't want to get in all the gory details of your project. So what is forecast scheduling about? It is really an approach that requires that the schedule by itself produces accurate forecasts and continues to do that. So I always define the schedule as a model of the project to forecast it. PMI has started to call it this schedule model. And really, I treat always the schedule as a model itself. So what is a great schedule then? A great schedule, as far as I'm concerned, is a valid and dynamic and robust model of the project. Valid, I don't need to talk too long about, probably. But dynamic, it needs to be a dynamic model. You need to have all the dependencies. And you need to minimize the hard dates, the constraint dates in your schedule, because otherwise it's not dynamic anymore. And it will require a lot of maintenance. It needs to be robust, and it will only be robust if you treat the dependencies in a particular way, which we'll look at soon. It needs to be a model. It needs to be a deliberate simplification of the reality. Have you ever met an architect who wants to sell a house, and in order to convince you that, you know, this is a great house, the architect actually went ahead and built the whole house? Built it already, and then took you through it, and here's this bedroom, and there's a kitchen, does it look great, etc. So do you want to buy it now? No, of course they don't do that, right? They create a miniature maquette of the house, and that's exactly what we do. It always drives me crazy when schedulers say, Eric, you know, my reality is different. It's more complex. This is it, and the scheduling tool can do that. I say, relax. You don't need to do that. We're not accountants. We just need to have it forecast, and we need to be in a good ballpark with our accuracy. Averaging out is very legitimate, and things like that. We need to deliberately simplify and keep the schedule lean and mean. So question to you, do you enter dates into Microsoft Project? Start and finish dates? No? Yeah, few. Not in the start and finish date fields, I hope. And whom of you use finish or later than constraints for capturing their deadlines? Their due dates, the finish no later than constraints. All right, not too many people anymore, which is really encouraging, because if you do that, this is what's going to happen. I'll just do a very quick demonstration. As soon as you enter a date, for example, on this task, it immediately sets a start no earlier than constraint. I'll push it out a little bit further. Where are we now? There it goes. And you can see that it immediately sets a start no earlier than constraint. It wasn't there just a second ago. So as soon as you enter dates in these columns, that's when you get these constraints. And you'll make your model a lot more maintenance hungry. The more of these constraints, the more of these icons you see, the more maintenance hungry your schedule will be. The more you'll find yourself continuously updating these dates more and more and more. And that's a very, very painful way of scheduling. In fact, you don't need Microsoft Project if you're going to do it like that anyways. You may as well stay with Excel. If you just use your scheduling tool as a date database, then you might as well use Excel. Scheduling software is meant to calculate dates, so please let it calculate dates. So what I'd like you to do to get you out of that routine, and that's what we challenge our students to do, is to highlight these start and finish columns and simply hit the delete key on them. I'm not kidding. Oh, you want to see dates? You just point to a bar and you'll immediately get the dates if you want to see them. But here they're read-only, so that really helps. If you are used to setting finish no later than constraints, you are also wrecking the forecast model. I'll set a finish no later than a constraint on this milestone. Let me set it on the 21st. Oh, no, a little bit later. Let me set it on the 28th. And you can see that nothing happens yet. The constraint is showing up with the red dots. You need to look for these red dots because they are the hard constraints that can cause scheduling conflicts. Now I'm going to push my dynamic model through that date, and this is what you'll start to see. Do you see it? How good a forecast model is this model still now? It's broken. Where did it break? Does anybody see it? This is where it breaks. You can see that the hard constraints are stronger than dependencies, and it basically wrecks the whole downstream forecast in your entire model. If you have a few of these constraints in a 10,000 task program, I am absolutely convinced that you have no idea where your program is really at. A 10,000 task program, but just a few of these constraints and a few of these bent dependencies. So let's look at a better way of doing this. What I would like you to use is this deadline feature. The deadline feature is more forgiving because it actually allows you to go these tasks through the deadline date. But it will give you a warning nevertheless. What I should have done, of course, is taken my constraint off as well, because otherwise that is still bothering us. So now I'm going to push it through it again, and you'll see that it is happy to go through the deadline date. However, what you will see is this red flag that's immediately raised, trying to make you aware that the deadline is missed and that you do have a scheduling conflict that you need to address. So this is a better way of going, and you've not wrecked the downstream forecast in the model, and even a 10,000 task program, integrated master schedule, working with several deadlines, will be forecasting quite well entirely. So this is one of the basic things that people need to start considering when they really want to step up and start using scheduling software as through scheduling software by trying to build a perfect project thermometer. So we did that demo. So capturing this, how can you capture the dates that you promised without killing the forecast model? Use the deadline date feature. Let's go to the next item. What about the WBS? This is a matter of modeling, of deliberately simplifying the reality of your project. What if you had the choice? You can either break down your project into phases or deliverables. Whom of you are the phase-oriented people? Whom of you are the deliverable-oriented people? You can see it's always a big discussion, right? It's not entirely 50-50. I saw perhaps 60-40 in favor of the deliverable-oriented folks. What are phases? Phases are warm and fuzzy little things. They're just grouping mechanisms. That's all they are. So do they provide any kind of like insight and control over your projects? Do they make clear commitments with teams, with project teams, with team members? No, they don't. And this is where deliverables always beat phases, hands down in my mind. Because if I'm contracted on basically putting a list of requirements together, as opposed to researching the requirements, if I'm contracted like that as a contractor, I can basically just sit down, kick back, be physically present, and do absolutely nothing because the client didn't ask for anything, right? So ask your team for something concrete that is tangible, and that's a deliverable. So that's a much better way of modeling your project that will set everybody walking in the right direction instead of being artfully vague. Now, sometimes you can have a phase and a deliverable orientation. The phase orientation is then typically on the higher level, and there should be at least 2 or more deliverables in each phase. If that's not the case, these 2 orientations start to fight with one another, and the phases should then lose out, typically. And really each project you can break down in a purely logical way where you basically take the overall product, and it's very easy, of course, for a tangible project like a new aircraft, because you just kick it apart in its components. So those are the easy projects to do it with. It's a lot more difficult to do it for a new software development project, for example. What are the deliverables there? Well, those are the features, the user stories, the requirements that need to be met. Those are the things, those are the components, basically, of eventually this new software. But even in a very tangible project like this, you also have a lot of less tangible kind of deliverables, all kinds of support deliverables, and then we shouldn't forget, of course, the project management deliverables. And they also need to appear definitely in larger projects. A question that a lot of people struggle with: too little or too much detail. Now, some organizations go about this in a very interesting but somewhat simple way. They say, level 3. You shall have level 3, otherwise it's not good. Or they say, it has to be 40 hours, or 80 hours, or whatever the absolute number is. And when we look at many different projects, some being a month long, some being a year long, that just doesn't work for us. Because the 40 hours may work well in a 6-month project, but in a 3-year program, it does not work. So what does work in every project? We found that the following rule works quite well, and that's the 1%, 10% rule that we eventually came up with, something that is pretty well universally applicable. The durations of the lowest level detail tasks should be within 1 and 10% of the project duration. For example, you have a 3-month project, which is more or less 60 business days. So that basically means, and you typically know this right up front already, right? When you start planning your project, well, I'm in a 3-month project or in a 6-month project. And really, that's the order of magnitude that you need to know right at the front. And right at the front, you also know then that if you find yourself creating detail tasks that are smaller than half a day, that you're probably creating too many tasks. And really, we've looked at schedules of 1,400 line items, and the person had a tendency to be very detailed, very checklist-oriented. Reminders to self, to-do list items, all that stuff was in the WBS. And it really, when we boiled it down, it ended up to be a 400 task list. And of course, a 400 task list is much easier to maintain when you get really busy during the project execution than a 1,400 line item. And you also know right away that the detailed tasks should not be larger than 5 days. So how can you check that then in your schedule? Well, what we do already with all the books, all the editions of the books that are published, we've already provided filters for people to do these checks. What we've done now is we've gone actually a step further, and we actually took that whole checklist in the back of the book and built an application that automates most of these checks. Now, we found that we actually had 81 checks, 50 of which we could automate, and 30 really require a little bit of an expert eye. Some things like checking if your WBS is well formulated is something that no software will ever be able to automate. What do we look at there? The deliverables should be nouns without verbs, because if you add a verb to a noun, then it becomes an activity, right? So for all the different items, milestones, and activities, we look at certain things. But then if you want to do the check on if the project has the right level of detail, you can immediately see after I ran it that it violates the enough detail check. So you click on it, and immediately it filters out all the tasks that are a little bit long. Now, as a schedule evaluator, I would be most worried about this one. That's 20 days. And so if you want to see it in the context, then you click on it again, and it will immediately highlight the violators in their context, and you can start improving your schedule. As an assessor, you might want to apply this judiciation by going to this interface and immediately tagging off. Well, perhaps I'm not too worried about these ones that are just above the 10%, but I definitely want to keep this one as a violator and to be written down in the report. So this is a tool that really helps the schedulers themselves to implement some of these best practices of scheduling. So back to the slides. Let's talk a little bit about dependencies. Dependencies are a great tool. A lot of people, though, intuitively don't find them very easy. In fact, I have met a 15-year experienced scheduler who, even after scheduling 15 years, still was kind of like mystified by this whole concept of dependencies. And what I found is that he was just looking at these dependencies in the wrong way. Basically, what we want the dependencies to do is we want them to start recalculating the rest of the schedule, such that our schedule becomes this perfect project thermometer, right? And really, if one thing changes in our project, then the ideal situation would be that we would have to change or update only one cell in our whole model. And scheduling software is working very hard for us. It recalculates it, forecasts it well again. This is what I've always called the principle of dynamic scheduling. I used to publish books under that title, Dynamic Scheduling. And this was really what it was all about. And I identified the practices that would support this notion. So let's see what kind of schedulers you are. What I found when I sat down with this very 15-year experienced scheduler is I found that he was just simply trying to sequence tasks. And that's even what the PMBOK asks for. So the predecessor always needs to precede, and the successor always needs to succeed, right? So let's do a test. See if you are a sequencer or if you are a modeler. Whom of you think that in this particular situation, it's a university exam, whom of you think that Schedule A is the best model of this particular situation? Go ahead. Schedule A. Whom of you think it's Schedule B? All right? This is a good discussion because we're more or less 50-50 split again. So let's talk about it. The Schedule A folks, by the way, are the sequencers amongst us. The Schedule B folks are the modelers. What you tell the software when you do Schedule A is that you basically tell the software by creating a finish to start dependency here, is if the preparation takes longer, what happens then? You want to reschedule the exam. Now, question to you, have you ever tried to call up your university professor the night before and say, sorry, sir, difficulties getting through your 800-page book, and could you please move it to next week, please? Could you? What would be the likely answer to that polite request? See you next year. So this model, you're telling the software the wrong thing. Also, when the prof single-handedly reschedules the exam, what will happen in this model? It will go detached. This task will go there, the preparation stays here, and by the time the exam comes around, you've forgotten everything. So also from that respect, this is not a very robust model, right? So what I would like you to start doing is start treating dependencies like impact relationships. I want you to start drawing, and that's a very simple way of explaining it to people. I want you to start drawing these arrows in a direction in which you want the impact to flow down through the rest of your schedule. That's all you need to do. It's that simple. But here's the trick. if you start doing that, you'll see a funny thing. And this model works indeed very much better. If the preparation takes longer, it will backfill here. And it will basically tell you that you should have started earlier. So you're in trouble, right? It immediately creates a schedule conflict. If the professor moves this exam to a later date, it'll take that task with it because the impact relationship goes to this task. As you can see in just those two changes, the one model works a heck of a lot better than the other model. And that's, even though it's a little bit an artificial example, but it gets the message, it drives the message quite clearly down to the people. If you start thinking about dependencies as modeling relationships, though, as impact relationships, you will find that the PMBOK sets you off in exactly the wrong direction. Because in this case, we do need a finish-to-start relationship because the end of the writing process should drive the start of the printing. And write is the predecessor, the print is the successor. Have you ever managed to print something before you've written it? You know, I haven't, so if you find a way to do that, please let me know. Here in this example, though, you'll see a funny thing. The successor precedes the predecessor. You know, the predecessor is always the task from which the arrow stems, and the successor is always the task where the arrow goes to. As you can see, the impact goes in this direction, and now the successor precedes and the predecessor succeeds, actually. This is exactly the struggle, the mental struggle, the puzzle that this 15-year experienced scheduler didn't resolve in his head. This is what he had been struggling with for 15 years. Once he realized this, he became a very dedicated modeler. So what I typically say is, let's rewrite the PMBOK. So I promise you, right, we will rewrite the PMBOK. Here it is. We need to start thinking in terms of predecessor and successor as driver and dependent tasks, rather. And if you just treat those fields in Microsoft and in any other scheduling tool, by the way, predecessor field and successor as the driver, the dependent fields, then you're going to be much better off. And you'll save yourself quite a bit of time. You know, when I show this slide, this is when project managers suddenly shift to the tip of their chair. This is where I catch them. This is where I get them to become modelers. Because even in a small, relatively small project, you know, you end up with about 180 changes. Why? Because you need to update each task at least once, some twice, and then you have people falling sick, needing replace, new requirements, and all kinds of change requests, right? So you end up with 180 changes. If you have this date-entered model of your project, you now have to update all the dates. On average, 50 tasks, start and finish dates, that's 100 dates. How long will that take you to update 100 date fields? Good luck, right? Are you going to go home at 6 o'clock at night? Because you're done with your schedule already, dynamic modeler. Or are you going to spend another hour on your schedule? Because you have to update 100 dates. You know, that's the choice that you have. And obviously, a lot of people do it for 1 or 2 weeks, and then they say, heck, I'm going home. I'm going to go to my family and friends, and let's forget about the schedule. Let's shelve it, and bye-bye. This is how we get people to do that. Now, these checks on the network logic, again, we provide filters with it, but just want to show you a neat thing again, that our forecast scheduling app also picks up on that. Logic should be on detail tasks. So here is a summary task with detail, with a dependency. As you can see, it comes out very quickly. So let's take care of that. All right, this is now a pass. Let's go to the ends linked. Click on it again, it shows them in context. Here you can very clearly see an open end. Oh, what should it drive? Well, probably the milestone. As you can see, it immediately displays a successor field, so that's task 7. And so that problem is solved. Let's go to the next, that's page down. Oh, that's all, I'm done with this one. And so people can just start clicking through these red axes to improve their scheduling. We think that by providing a tool like this, which is really not so much, it's also an auditing tool, but it's really more of a schedule improvement tool, that will actually slowly but surely taking all excuses away from people to not start creating decent models of their projects, right? You need to give them the right knowledge, you need to give them the training, and then perhaps a tool, and then there is really no reason at all anymore. It's going to save a heck of a lot of time if people really start doing this. And we've seen that in some organizations, the changes were quite dramatic. Now, what can you do in terms of resources and minimizing the effort? Instead of putting all the Tom, Dick, and Harrys in there, we sometimes say to organizations, well, you are in a situation in which you have to be careful what you're going to expect from your schedulers, because Tom, Dick, and Harry schedules will require perhaps hundreds of resources in there, right? Perhaps you're not quite there yet, and in terms of your scheduling maturity, let's do just generic resources or team assignment pools. You would say, well, Eric, that's too rough, doesn't cut it. What do you lose by doing this? The only thing you lose is being able to create personalized to-do lists, right? By doing that. You can still do workload leveling, because now the max units is 300%. You can still explore scenarios as to what a good forecast for your projects would be. And it's a heck of a lot easier. And you can play with these max units also much easier in terms to find out, what if we add half a programmer more to this team? Where will the project end up then? So it actually provides some additional benefits that would be very cumbersome in a model like that. So no matter what, we often try to, even if people want to go eventually to Tom, Dick, and Harry type of schedules, we try to get organizations to start with populating the schedule with generic resources. All right, let's go to some optimizing. Determining what the optimal schedule is. The thing here, what you run into when you try to find what explains the duration of my project schedule, is that the critical path theory, as I call it, the critical path 1.0, is weak. Because sometimes, it displays too many tasks being critical. Here you can see 2 paths, one path that runs like here and one other path that's significantly shorter. But that's also red and colored, highlighted as critical, because of the critical path 1.0 definition. Even this path can barely meet this deadline. That's why it turns critical as well. I don't know, have you seen schedules in which everything was critical? Whom of you have seen a schedule like that? So where to start then, right? That's really difficult. You don't see the most critical path. And you're supposed to start optimizing the whole schedule all at once, right? Now, that's like eating a loaf of bread and pushing it all through your throat. You need to eat a loaf of bread slice by slice, right? So that's a problem. Sometimes you get too few critical tasks. Now, that's a problem as well. Whom of you have seen that you got just a few pitiful critical tasks sitting in your schedule? And that's where also some of the weaknesses of critical path 1.0 come through. Now, what causes that? Here they are again. Constraint dates can cause that. Elapsed durations. I'll show you this, actually. That's much more interesting than looking at this list. So what breaks a critical path? I'll open up the next demo file, and here it is. So here we have a pretty good schedule. You know, it has a wonderful critical path, right? So that's something like that you would like to see in your project. And so now, but you get to the nuances of your schedule, and the meeting, you know that the meeting is going to take place on, let's say, next Tuesday, so you drag it over there. By doing that, you've now set a constraint. See, here it is. And your model is not very dynamic anymore, but worst of all, you've lost your critical path because now there is a little bit of slack on all the upstream tasks. This is how your critical path breaks. That's one of the things. Just to zoom in a little bit. See that? That's what colors all these tasks that you see there blue. Just this constraint adds total slack there and breaks the critical path. So that's one thing. Let me quickly undo that. Or I want to see my complete critical path, right? So people find themselves that they stop using these more advanced features, even though this was a legitimate thing, right? We know that the meeting is going to take place on that Tuesday, so why can't I stick it on the Tuesday? Well, I lose my critical path. That's not very nice. Here's another thing that makes you lose your critical path. If you have this meeting, for example, and you put a task calendar on it, where you say, we're only going to meet on Tuesdays, steering committee meetings, right? Typical example. As you can see, again, it has created a little bit of total slack on those tasks. And of course, it then breaks the critical path again. See that? So task calendars also do that. Let's not use task calendars, folks, because we lose our critical path. We need a critical path, right? Here's another thing that makes the critical path break. If you have a task like drying of paint, drying of paint can basically continue through the night, right? So what some people do is they enter an elapsed duration or E-day duration. But there it is. See, again, it breaks the critical path. See that? A little bit of slack now, and all blue upstream. So this is what makes critical path too difficult for, but we need critical path in the whole concept of forecast scheduling, obviously, right? So we need to be able to do critical path in a very easy fashion. So this is really disconcerting for a lot of people. And here's another one. If you have this task and you assign a mover to it, and the movers only work in the weekend, then as soon as I click the assign button, you'll see the effect. Look here. There it goes. Again, task is forced. Whenever you do a little bit of forcing of the schedule, that's typically when the critical path breaks and really messes you up. So once we realize all of these things, and we really want to continue to do forecast scheduling, we started to realize, there's got to be an easier way to do this, folks. And we still, in a schedule in which we use all these constraints and task calendars and elapsed durations and resource calendars, we should still be able to do critical path easily. So after we define this critical path 2.0 standard, by the way, if you'd like to receive this 50-page document, give me your business card and I'll send it to you. So I decided, okay, let me put now my money and let me invest in this to make this easier for people. So we developed this complete critical paths tool that can actually do that. In just about any schedule, it will still, even if you use these more advanced features in the scheduling tool, it will still tell you what the most critical path will be. And it can even pop up near critical paths. And it can even go across schedules in an integrated master schedule. So it's quite a powerful tool, actually, that really deserves its name of complete critical path. Not only will it highlight it, the most critical path, explaining the finish date of the project, but it will also tell the story of that critical path, as you will soon see. It has found 23 critical tasks, as you can see, and it will tell the story of this path. Here, this gap is caused by this SNET constraint. Oh, is there a SNET constraint? Oh, I'd forgotten about this little guy here. This gap is caused by the task calendar. Oh, there it is. There is indeed a task calendar. There it is. See, the indicators column is actually quite good because it will remind you of these things. And as you can see, it has even picked up on the effects of the resource calendar. So if critical path becomes that easy again, wouldn't you want to do it? Whom of you had kind of forgotten about critical path? And, you know, it's too tough. This is the reason why it was so tough. But wouldn't you want to do it again if it is indeed that easy and straightforward? This is the way critical path is supposed to be, and this is as easy as it should really be. And as you can see, it's quite doable then. So really, I've demonstrated to you many of these factors here that break a critical path. One factor I've not talked about and that is workload leveling. We need to talk about that a little bit more. So the critical path 1 definition, the most current critical path 1 definition is currently, and it's a lot better already than it was in the 4th edition of the PMBOK. Literally, the 4th edition definition started with generally, but not always. Do you remember that? It was awful. Now in the 5th edition, it's cleaned up quite a bit already. It's the sequence of activities that represents the longest path. And this basically, ladies and gentlemen, if you do it like this, and if our scheduling software starts calculating like this, then it will take care of several of the factors that I listed on the previous slide. It will take care of hard dates. It will take care of calendars and any combination thereof. It will also take care of elapsed durations. So that's all good. But what it will still not take care of is resource constraints. So we eventually settled on this definition. It's a little bit longer, but it has a few more finesses. It's a subset of activities. We like that term because it really focuses on what critical paths should do, right? It should boil down the 900 task list to 100 or so tasks that really drive and explain the project finish date. And so that's what we wanted to do when all scheduled data, and in the critical path 2.0, we require that the scheduling tools can also deal with resource constraints. So critical path 2.0 is an enhancement on critical path 1.0 because we require that the scheduling tools will be able to handle date constraints, calendars, and also resource constraints. And the resource constraints is where the biggest challenge is. So how to get a complete critical path? Let me introduce the whole issue a little bit further. Easy question to you, folks. What is the critical path in this non-leveled schedule? Right, it's task right X or right Y, folks. Come on. X, right? Longest pole in the tent. So we got it all right. That's the right answer. But now, a difficult question. And only 27 people, I keep count. It's easy for me to take count. Only 27 people out of the thousands of people I've asked this question have answered this question right. All right, so think twice. What will our scheduling tools indicate to be the critical path in this workload level schedule that really forecasts the project much better than that, right? Because this is fooling everybody. If Harry has to do both tasks, it's never going to happen within this 3-day time frame. So this is a better forecast already. I'm much happier with that. But we may have lost our critical path. What do you think is the critical path? What does critical path 1.0 calculate? Why? And why? That's right.
It doesn't account for a discretionary dependency like this that's based on resources.
Yeah, it's a resource dependency, right? There's no arrow, so it's not a logical dependency. So what does our critical path 1.0 forward and backward path calculation do? It basically thinks that this task can shove into this area just like that, because the critical path 1.0 only looks at logical dependencies, does not look at resource dependencies. We had conveniently forgotten that the critical path 1.0 was built on this one assumption that makes it, in this modern time, a little bit weak, which is you have access to unlimited resources. Now, whom of you have access to unlimited resources? Please tell me. Please tell me. I'm going to apply for a job at your organization because for once in my life, I would like to be in a situation of unlimited resources. Wouldn't you? That'd be great, right? Ah, that'd be so wonderful. This gentleman is number 28. He got it exactly right. Congratulations. You deserve a book. Could you pick it up at the end of the presentation? You really deserve that. Most people think like this way. If Harry finishes this task late, well, this task needs to be rescheduled, right? And you can see that a resource dependency is almost as powerful as a logical dependency. So what some people then say, well, Eric, just set it, model a resource dependency as a logical with a logical dependency, and the whole problem will be solved. And I said, no, 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 don't do that. Why? Because a resource dependency is fundamentally different from a logical dependency. Because a resource dependency allows you to have them switch places, where a logical dependency should never allow you to do that. So if you start modeling these resource dependencies by creating extra logical dependencies, you create deliberately a suboptimal schedule. That when things start to shift and move and people get reassigned, you now definitely have a suboptimal schedule. You should not do that, ideally. Instead, use different features, use logical dependencies for practically necessary impact relationships, and use the resource workload leveling features for resolving this problem. But if it breaks the critical path, we also need a more powerful tool that can actually then show us the resource critical path as, or a resource constraint critical path. And so we also need to be able to do that. Now, let me show you a way which we can do that even. So here you can see a clearly resource constrained schedule. See here, poor Sam has to do 4 things at the same time, right? Now notice what some people say is, don't do workload leveling, don't. Have you ever heard that? Whom of you have heard that? You scare the bejesus out of each other, right? Why do you do that? Because you've applied it and you saw that the workload leveling engine produced garbage results. You know, it actually had the audacity to schedule it, putting in the foundation of a house way later than building the walls and putting the roof on top of it. How is that possible? My answer is, folks, workload leveling is only going to work well if you do diligence, if you make sure that you have all the logic. You can see how very carefully I've crafted this logic. And I've made sure that indeed all the starts and all the ends are linked up. That's what you need to do on the detailed task level. And once you've done that homework, you can now, without any problems, indeed start doing workload leveling. if you have captured all the important impact relationship, there's no problem at all anymore in clicking this button. Except for the fact that if I undo it, you can see that we started with 70 days, and when I click this button, it's now suddenly 119 days. So we may need to do some optimization again. We need to, again, know what explains the forecasted date, and this forecasted duration of 119 days. And you can see that critical path, and Microsoft always hates me for this demonstration because it shows that Microsoft Project doesn't do a very good job. But I can guarantee you, folks, if you do the same example in Primavera, it's going to show up the same thing. This is an issue with the critical path 1.0 theory. We need to have a better theory, critical path 2.0. You can see here the big gap already, and this is typical in a workload level schedule, that you start seeing these huge gaps. What I'll do is I'll apply a quick filter on critical. And there you start seeing these gaps. Have you ever seen gaps like this in your critical path that you had no clue about what it was caused by? Well, here is the answer, folks. The tool doesn't do the critical path theory. Critical path 1.0 just does not do resource critical dependencies and resource critical paths. So let's see if our tool actually does that. And I'm pretty hopeful that it will. We need to ask, though, for a resource critical path. And again, our hope is that this will tell the whole story about this project and explains the entire project duration for this project. So here okay. Oh, that's right. Thank you. No, I need to run it again. I've overlooked something. Resource critical path, there it is, that's good. Entire schedule. So the scheduling tool should eventually, even in a workload-leveled schedule, as you can see, it now tells the whole story and really explains the entire project duration. If you zoom in here on this, on Sam's tasks, you can see that there's no gap there anymore. They're all now on the resource critical path. And that's what our scheduling tools should eventually start doing, because then we can really start making use of these powerful workload leveling features that can really address these resource-constrained projects. If you're working in a time-to-market organization, you're always stressed for resources, right? And you always really need to do, actually, this analysis. If you don't, then you are often really in the dark, which is very, very painful. So we did that. Let's start talking about, by the way, why are you not asking questions? If you have questions, please. And there will be some time still. How to update your schedule in such a way that it will continue to forecast your project. Let's talk a little bit about that. First of all, whom of you always try to maintain their baseline schedule? A few people. Whom of you set the first baseline but then don't bother with it again? You don't set the first baseline. What is this, folks? Are you all asleep now? That's very easy, right? Setting a baseline in the first baseline in a schedule. The pain is maintaining the baseline. So emphasis on this word maintain, right? Setting the first baseline is very, very easy. Let's just switch back briefly to the schedule. Just in case you don't know, you should know that setting a first baseline is as easy as making 3 clicks. 1, 2, set baseline for the entire project. third click, bang, it's set. That's all you need to do. Right now, you already have the great benefit of being able to compare your actual durations with your original estimates. And perhaps even do work comparison, actual work with baseline work. That's the benefit you get already. So you can learn, you can become a better project manager already next time around. So why do we need to maintain our baseline? When you add new tasks, you would need to, if you want to learn from their estimates as well and compare them, you need to quickly baseline. Approved changes. You're probably in an earned value world. All right, when we start talking about approved changes. Maintaining your baseline is like going to a root canal treatment at a dentist. It really is. What do you need to do? Well, first of all, to maintain a baseline, insert new tasks. You need to make an impact analysis, right? That's the first thing you need to do. How can you make an impact analysis? Well, you take a quick snapshot of all the dates, use the same feature and set an interim plan. First step. Then you incorporate the changes into your schedule. You hook it up. Then you see the impact. So you write the impact up in your change request. Schedule impact 3 weeks, cost impact $15,000. Then you send it off. You get it approved. You get it back. And then what you need to do is you had undone all those changes because they were not approved yet, right? Or you may have used a new activate feature, which is a great feature for that situation, actually. And so you might have to recreate it if you didn't do that, which is very painful as well. But before you do that, you need to find out which tasks are affected by this change request. How can you find out? You need to set the snapshot again of all the dates. Then you need to enter the changes. Then you need to run a filter that filters out all the tasks that are impacted by this new change. And then what you need to do, and that's the last step, you need to use this very specific feature. After you've run the filter, on which are changed, you need to go back to the set baseline dialog box, select all those tasks that filter produced, and use this specific feature to update the baseline and maintain it. Do you understand now why I say maintaining your baseline is going for a root canal treatment at the dentist? It is so incredibly painful. So let's think about it. Do we need to maintain a baseline to implement this notion of forecast scheduling? Heck no, we don't need it. Now, if you need to do earned value, don't throw away your baseline, okay? And please continue to maintain your baseline because you're going to be required to do that. You're going to be required to go to a root canal treatment at the dentist every month or so. But if you don't do it like this, you just set the first baseline, you forget about maintaining your baseline. Don't need to do it. The only thing you need is a deadline. And you can forget about maintaining your baseline. Because really, this is the perfect project thermometer, right? As long as you have the model shift continuously and give you the feedback on the deadline, you're good. So then, updating the schedule. Whom of you collect percentage complete? Yes, we do it, right? We love our percentage complete. I think it comes from the construction world, really, because that's where you have to do percentage complete. It's easily measurable as well, right? You need to put in 100 miles of road. Are you at 60? Well, perhaps you're at 60% complete then, right? Nobody argues. Yeah, then we have some additional factors to consider. What have you found that when a team member says, I'm at 90% complete, what a team member means by that? Could you give me some funny examples? 90% spent. Yeah, that's a great one. It's very defendable also, right? You found it just that as a proof that they don't know what they're talking about. That's a very interesting one. Go away, yeah. Get off my back, right? Aha. So that works in your very specific situation. Very good. Oh, you set it right back to 50. Interesting. So if you ask for percentage complete from your team, you're really setting yourself up for failure, right? Because it's so artfully ambiguous. This is what we want it to mean, and this is what the gentleman there already said. Programmers I found to do this, they've solved the logical puzzle on the top of their head, right? They've not written one line of code yet. And they feel entirely on top of the hill. Oh, I'm at 90% complete. Don't worry, it'll all be okay. And it gets worse from here on forward. And this one was also mentioned. So what should we do? And this is a recommendation that we make. If you are in construction projects, yes, by all means do percentage complete. It makes sense. Individual independent assessors will come probably to more or less the same percentage. But looking at a software project, assessing how far you are, leads to totally different answers often between independent assessors. So what is a better strategy? The only thing we really need to implement this notion of forecast scheduling is continuously asking for remaining durations. And you can basically update your schedule very quickly. You just pretend as if everything ran according to schedule, but then you just punch in the remaining duration still for those tasks that are still in progress. And because people have learned in the meantime, you get pretty good remaining duration estimates now. And then let you do the schedule, do the work, and you're going to be really good. So really, you only need to ask for this. If you have very little time or very little cooperation from your team members, only ask for this, and that's all you need. If you have a little bit more cooperation from your team members, and you actually want to really start comparing against your baseline durations, then you also need to ask for actual durations, or actual work for that matter. And that will give you that feedback on your original estimates, and you will become a better project manager the next time around. And please let Microsoft Project calculate the percentage complete. Then it's a much more meaningful metric. Yes?
Are you always in one task type then, or are you starting in fixed duration, moving to fixed work, or adding one status to another?
Really good question. The question was, do I always use one task type? And the answer is, well, I need another 20 minutes to explain the whole story. But during the updating, I encourage people to use fixed units, non-effort driven tasks. Because that's what works best. Because if you start entering remaining durations, you're constantly messing with the duration in the formula, right? Duration time units equals work. If you fix the units, then you mess with the duration, then it will always continue to recalculate the work. And that will give you feedback again on your original estimates. So that's what most people need. Now, there are some nuances there, but that's really the general answer. So there are three task types: fixed duration, fixed units, fixed work. You have a three-variable formula. And a three-variable formula works really well if before you make a change to it, you protect one value, and then you make a change on the second, and you always let Microsoft Project recalculate the third value. And what 90% of the people need is, when they're updating their schedules, they need to protect the units, the percentage of people working on the task, in order for the work to be recalculated. So update the schedule to forecast. Make sure that you put all the completed work in the past to the left of the status date and all the remaining durations in the future. If that's not the case, then you somehow have a time machine. So I always ask the project scheduler, where's your time machine? You left these actuals in the future. How did you do that? Did you travel to the future and now you came back to the now? And here's the remaining duration. In the past still, you're going to do that this coming week in the past. You must have a time machine. So visually that looks like this. See, here is an actual in the future. It shouldn't go past the status date. So really, it should be pulled back and it should be scheduled like that. This scheduler forgot to update the actual start date probably. The other way around, it looks like this. Remaining work left in the past. There it is. This little bit of work should be brought to the future, and it will work out like that then. All right, how to implement forecast scheduling? You need to pay attention to these things, and it's a bit of a summary of my presentation. These are basically the main points that I've made. So, right level of detail using dependencies, treat the dependencies in a particular way, consider generic resources, question yourself if you really need to maintain your baseline schedule, find the critical path, or if you're in a resource constraint and workload level situation, find the resource critical path, and make sure that it always explains the entire duration, and update your schedule in a particular way. So that's my presentation. There's some time still for some questions, if you still have the energy for it at this late hour. And of course, if you want to participate in the draw for one of my 5 books, then please drop your business card still. Questions? Yes? Yeah, critical chain is yet a different approach to scheduling, but it also incorporates the notion of a resource-constrained critical path. So that's part of critical chain, and also obviously a part of critical path 2.0. Where critical chain and critical path 2.0 differ is that critical chain also says you should schedule everything as late as possible, you should build in buffers, and not just the main critical path, but also the secondary critical paths. And you should prevent multitasking as much as possible. So it has a lot more than just a resource-constrained critical path, and that's really the difference. We are already very happy if you just create or find the resource-constrained critical path in your schedule, because that's really what you need for forecast scheduling. No, absolutely, no. Any other questions? Yeah. 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 So the question is, does that 81-point checklist also translate like an overall project score of the schedule quality? Not currently, but it's a great idea, and we'll definitely be adding that to the tool. What you can already do is this small list that it has right now. There's a button on it which you can expand it, and you can immediately see the whole assessment and how many violators there are on each check. Sorry? Yeah. In the overview view, it shows all the red axes and the green check marks, as well as the number of violators in behind each check. So it is all there already. We just have to somehow calculate an overall schedule quality score still. Any other questions? No, it's even though I call it an app, it's not an app because we actually needed to be able to write to the schedule, and Microsoft Office apps don't allow you to do that yet. So it's a VB.NET application actually. But as soon as we can do that, then we will publish it also as an Office Store app. Absolutely. Yeah. Any other questions? All right, then let's transfer to the ceremony protocolaire. Would you like to start them, Ellen?
Okay, I just want to tell you, Mike back there needs his card back or he won't be able to get into lunch.
Oh.
Okay.
And I promised one book already to the gentleman there, right?
Oh,
So we're going to draw now four books.
Okay, well, here's one. Chris, from American Board of Radiology. Okay. And let me give you that. And,
I'll draw the next one.
okay. You got another one there?
Frank Maratolo. Is Frank there? All right. That was two, right?
Yep, there's two more left.
The third person is Jeffrey Brady.
Jeff?
And the fourth person is, I'll mix them up quite well again. And the fourth person is Eric Semple. All right, ladies and gentlemen, thank you very much for spending 75 minutes with me.